vertex, same as your turning point. Your vertex will help you do your increasing, decreasing. Decreasing from negative infinity to 0, increasing from 0 to infinity. Okay? So this was just a nice information. Your axis of symmetry is the vertical line that goes through the turning point where you have symmetry on both sides. So it's an x equal line, and it's the x point of the vertex. And this vertex, we're going to call it HK. Okay? So the axis of symmetry would be x is equal to whatever h value we get for our vertex. To go, when they're offset, it's just they're offset a little bit from your axes. Same thing. Your vertex is the lowest, the minimum point. This is the highest point, opens down if it's negative. When a is less than 0, when a is negative. When a is greater than 0, a is positive. It opens up. These are on your sheet, so I just thought that that was a nice way to look at it. Also, there's a nice example of completing the square. I am going to walk through this today, but they also walk through it. So, this way you have a copy of completing the square when a is not 1. This is our goal today, to get it into vertex form. And if I gave you this parabola, or I gave you this one, which one could you sketch without your calculator? The first one or the second one? The second one. Where would you start with this one? Over to the right, 2, right 2, up, left 2, left 2, then what would you do? Okay, stretch this first a little bit, right? And then you would take this and shift it down 1, my thing is off here. Shift it down 1. So could you do that from the original? No, really difficult from the original to do, but you can from this, your vertex form. So today we're going to spend some time putting your parabolas into your quadratics, into your vertex form, so that you're able to graph these from your transformations. And we spent a lot of time on your transformations. So now we're going to spend some time in how do I get this form to my vertex form. Okay, I just thought these notes would be kind of helpful to help, to help you remember. Okay. Alright. So this is the form we want to get to. Now, we want to remember that A, it comes from ax squared plus bx plus c equals f of x. Okay, it comes from that. If A is positive, then it opens up. If A is negative, then it opens down. We're going to be doing a lot more with that A part in it. This guy right here, this is your vertex. And doesn't it stand to reason that it comes out the opposite way? Like when we see x minus 2, which way do we go? To the right. We go the opposite way. So HK is your vertex. So your axis of symmetry is going to be a vertical line. X is equal to whatever the value is at h. Whatever that h value is, that x value will be where my axis of symmetry cuts through. From this, we can also find your roots, your zeros of your equation. This is used a lot in Algebra 2 to find your zeros as an alternative to your quadratic formula. Remember your quadratic formula? And you don't have to write this down. I'm just wanting you to remember this. Remember this? Putting them in here when you couldn't find your roots? If you do this vertex form, we're going to find your roots so much easier because this side, your y, is set to 0. So from this, we can find your zeros, your roots, your solution. Okay, we'll be able to find all that. A lot easier than your quadratic formula. Do you guys remember doing that at all in Algebra 2? Using this form? Which first one? Find the zeros, the roots, the solutions. They're all called the same. They're interchangeable. Did you do this in Algebra 2 at all? Use this format to find your roots? It's so much easier. I'll show you when we get to it. We also deal a little bit with the imaginary roots in here. Just a little bit. Just enough so that if we had a negative under this radical sign, we can take it out and consider it an imaginary root. That's as much as we'll do with your imaginaries. So that we'll know if the highest exponent is 2, I expect 2 roots. Do they have to both be crossing the x-axis? No. They could be above the x-axis and be imaginary roots. But that's about all we'll do with your imaginary roots. So we are going to work at this one. And what we have to do to get here is complete the square. So we're going to start with something really much simpler to complete the square. We might have completed the square running it on both sides. We're going to run everything on one side. So we're going to start with this problem. This is not on your paper, so write this down with me. I changed the sign. I'm only doing that. Okay. Now, we want to be able to graph this. Can you graph this as it is? Unless you put it in your y equal, right? So we're going to put this in vertex form. In order to put this in vertex form, we need this thing right here. We need to complete the square of it. Okay? So we have to get this so that we can complete the square. We're doing this all on one side. Keep your x's together. If anything has to get factored out, it only has factored out of your x's. This is the part that we have to find the third term to complete the square. I need this to be a perfect square. I still have my plus 7, and because I added something, I have to subtract something. If you add 3 to an equation, you subtract 3. If you did this on both sides of the equation last year, if you added to one side, you added to the other side. But because we're keeping this on one side, we need to add and subtract the number. Now, complete the square says come to the b term. Take half of it. What is half of 4? 2. You start like this. Positive x plus 2 squared. We're making your perfect square here. So then we say 2 squared is what? 4. If we add 4, we subtract 4. So here is my vertex form. I combine these. And this is my vertex form of my parabola, my quadratic. Can you find me the vertex now? Take it out the opposite way. Because which way would we go with the plus 2? Which way would we graph this? To the left, right? So it comes out the opposite way, -2, but the k stays the same, 3. If you were going to graph this, guys, you would say, start here, here's my core graph, I would move this to the left 2, and then where would I move it? Up 3. There's your transformations, there's your vertex. There's your vertex point, -2, 3. it comes out. It fits this format, H, K. There's H, there's the K. Remember the H has a negative in front of it. Okay? Completing a square. You want to get a square out of this. So group your x's together. We're going to add another term to your x's so that we get a square that's duplicated, like x plus 2 squared, x plus 1 squared, x plus 1 times x plus 1. If you factor this is x plus 2 times x plus 2. There's your square. So leave a little space so that we can complete the square. And then go to this term, the middle term, the b term. Take half of b, which is 2. So x plus 2 is going to be your factor. To get this piece here, we say 2 squared, 4. If we add 4, we subtract 4. Okay, you want to try another one? Just for the sake of it? We're going to do one with a greater than 1, but I'm going to have to write it here.
Take the negative b divided by 2.
Say that again?
You said take the negative b and divide by 2?
Yes. Yes, you take half of b. Okay, so let's take this one.
Isn't that?
Take half of b. That's a negative. Just take half of b, whatever it is. It's 2, and then square it. So let's start here. Can you factor this? Is this factorable? No. This is what you did in Algebra 2 probably. You factored it using this. You did, instead of the quadratic, you completed the square. But we're going to put this in vertex form so you can graph it. Can you graph this? Go ahead. I wouldn't even know where to start. Right? So can I graph it in vertex form with a transformation? Yeah. So now, group your x's like this. Leave a space. Just rewrite it. Leave a space right there because you're going to find a third term. Oh, let me take out the 5. I wanted to do an even number. Let's try 4. Oh no, that's factorable. Let's go with 6. Let's do 6. I'm sorry, I just wanted to make it even so I don't confuse anybody. Now, you're going to find a third term here. You still have this piece of your equation, but you also have an equation. If you add something to a line, right, you also have to subtract it. So we subtract it. If you remember last year, you probably put 2 sides. You probably put the constant on the other side and then added and subtracted. But that one is a little bit different. This to work out nice. Can we make this a minus sign? Will I mess anybody up if I make it a minus sign? We did a plus, and this way the minus, I'll work the whole thing through and show you the roots. So, once we do this, we realize this has to complete the square. We take half of negative 6. What's half of negative 6? You write it like this. X minus 3. This was a positive. We took half of a positive and made it positive 2. We take half of a negative, we get a negative inside. And this is our perfect square. For you to find your third term, just go like this. What is 3 squared? 9. If you add 9, you then have to subtract 9. This right here gives you x minus 3 squared. If you factor x squared minus 6x plus 9, you get x minus 3 times x minus 3. There's your square, x minus 3 squared. So this is taken care of in this. Now all you have to do is combine those. So your equation says x minus 3 squared minus 6. Can you graph that? Is that parabola going to open up or down? Up. A is positive, right? It's going to open up. Where's your vertex? 3, negative 6, because you're going to move to the right 3 and down 6. 3, negative 6, and you're going to open up. These are why we did transformations, right? So that we can see where we're going with that. Now, to take this one step further, watch how we find your roots. See where it crosses the x-axis? We can find your roots without having to do your quadratic. You couldn't factor that original one, right? It wasn't factorable. You have to use your quadratic. But because it's in this form, y is 0. So watch. Watch how easy it is to find your roots. Plug a 0 in and solve it. We add 6 to both sides. How do you undo a square? You get a plus or minus square root of 6. And then you add 3. These are where your zeros are. Plus or minus radical 6. There's your roots. When y is 0, x has 2 roots. That's these guys right here, where they cross your axis. That's in lieu of doing your quadratic formula. So your complete the square does quite a few things. It puts it into a form where you can graph it. You can find the vertex. You can tell me where it opens up or down. You can find your vertex, your axis of symmetry. You can find your roots real nicely from this too. Okay? Isolate your value, your x's together. Those two terms, you have to come up with your new third term to complete your square. Because it's not working with the original. Okay. Now, sometimes it's not that easy because A is not 1. A has to be 1 in order for you to take half of B. This is the example that's on the sheet that I gave you. So let's walk through this. You're going to come here. You're going to group your x's together. Press your x's together. Pretend the 7 is off to the side. We need to make a new space here. And because we added, we have to subtract. Now, 8 has to be 1 in order for this to work. So it's not. That's a factor. What do they share, these two terms? 2. Leave the x's here. I need the x squared. Just take out the 2. I need to get rid of this. Whatever a is, remove it. Factor out a. So x squared plus 4x plus something that belongs to this group plus 7 minus something. Whatever a is, factor it out. In this case, it was 2. Leave the x's where they are. Now go to this middle part and complete the square. Leave the 2 out here for a minute. What's half of 4? So, x plus 2 squared. What is 2 squared? 4. Now be careful. 4 is trapped in my parentheses. Because the problem really isn't x squared plus 4x. It's really 2x squared plus 8x. So I have to distribute this 2 to get it out. So what's 2 times 4? I believe it really, yeah. I had to because I can't complete the square if that was greater than 1. But we're gonna bring down that 2 in a second here. I'm not actually putting it back in. Only for this guy. Bring down this 2 and combine these. This 2 in your transformation represents what?
Isn't it only 8 instead of 24 to 8?
No, you have to bring it out of this group. So you have to distribute this back out. 2 times 4, 8. You can't take it out of that parentheses without distributing it. Okay? Now, what does that 2 in your dilations give me? A stretch, a vertical stretch. So what's your vertex? -2, -1. If you were graphing this, you start with your 4, right? Where's your shift? Left 2, go left 2. I would do a stretch, which makes this a little narrower, right? Stretch it up. And then where? Down 1. There's my vertex, -2, -1. There's my stretch. That's where my 2 came in at my stretch. See it? We could never graph that from this equation. Could you? I could never. If we want to find the roots, we do this. We set your y equal to 0 because at the x-axis, y is 0. This is so much easier. I'm surprised you guys don't remember this from last year. Add 1. Divide by 2. And then take the square root. So the plus or minus 1/2 is equal to x plus 2. And then just move the 2 to the other side. These are your roots, your zeros. So plus or minus 1, and we can leave the radical 2 in the denominator. -2 equals x. That'll give you, and they're irrational, that's fine. They can be irrational. We couldn't factor those. We knew they had to be irrational because they were not factorable. So whenever you have an a that's not 1, you have to factor out a. A has to be 1.
Why did you distribute?
Because it was stuck inside this parentheses. Because it's stuck inside here, the only way to get it out is to distribute it out. Because technically that's not really x squared, that's really 2x squared. That's not really 4x, it's really 8x.
Are you supposed to make it a 4 before you make it a 4?
No, because you want to keep the 4 so that you can get your x plus 2 squared. But then to get your other number, you got to take it out of the parentheses. Let's try another one. These are good to make up. I can make these up at any time. Okay? I want to graph this. Can you graph this? So, you got to complete the square. You got to put this into vertex form. Your vertex form says 1 feet. Okay. This is your square, right there. So take your x's, rewrite this with a little space right next to it because we need a third term. Okay. Now, a has to be 1. I got to get rid of this 3. So let's factor out a 3 out of this little root. So this becomes x squared plus 2x plus something. 4 minus something. And let's follow your complete the square rules. What's half of 2? 1, and it's positive, right? So x plus 1 squared. Easiest way, what's 1 squared? 1. Why will this one never be a negative? I always keep writing plus. Why don't I ever write minus? How do I know it's always going to be plus? Because when you square a negative, what do you get? Positive. So whether this guy is x plus 1 or x minus 1, you will always get a positive in this part. Now, isn't that factorable to x plus 1 times x plus 1? Sure is. But look, it's trapped inside this parentheses. So 3 times 1 is 3. Now just combine your like terms. Bring this 3 down. There's your dilation factor. What's your vertex? Which way is this going to move? 1 to the left, so -1, 1. There's your vertex. Your axis of symmetry, if you're looking for it, is x equals whatever x value. X equals the x value. That's the line that's going to cut that in half at the vertex point. Okay? So can you give me the graph of this from here? Sure can. Much better than giving me the graph from the original one. Okay. Now, the only other piece that you would need to know is this piece, finding the equation. Sometimes we give you the information and we have you find the equation. So you're going to start with this formula. You're going to remember that the H and the K is the vertex, and A we might have to find. So that might be the thing that we have to find. So we walk through this and it says it has a vertex. Oh, I know this is H. I know this is K. So I substitute them in. Y equals A x minus 1 plus 2. I almost have it. The only thing that's stopping me is A. I gotta find the value of A. So if I can eliminate everybody else but A, can I find A? So the only other thing I can eliminate is my X, my Y. My X and my Y. So plug those in. What would X be? What would Y be?
Are you using a square?
Yes, I am. So what is my X and my Y? What is my origin? So plug this in. This is the same. Do you guys remember y equals mx plus b? Do you remember the point slope formula? Sometimes you had a point and you had a slope. And we always said, oh, you don't have to use this one. You can do this, find b, and then plug it back in because you can have a value for x and for y. Do you remember when we did this? Not really? This works the same way. Plug this in. What is 1 squared? Negative 1 squared. Subtract 2. Divide by 1. Well, that is, you don't even have to divide. You would if you had to. Had anything else. Now, plug this, remember, plug this back in. Hang on, give me 1 second. There's your equation. Which way does your parabola open up? Down. What's your vertex? 1, 2. You put this in your calculator and your y equals, and you look for the origin. Look for the origin to pass through. Does it pass through your origin? Is that a point? 0, 0. You get to see it. All right. Tomorrow, you guys are gonna be here. So if you are planning on coming here, you can work on your homework in class. If you don't plan on coming here, you have to do your homework at home. And then it'll be due. What's tomorrow? Tuesday, Wednesday. I hate a day off in the middle of the week. Tomorrow's my day off.
So what we're doing tomorrow is homework.
Homework.
Okay.